2, but this is 1 by R total. We need R total, so that's why here what we have done, which is nothing but reciprocating this 18 by 72, so that is 72 by 18, that is nothing but 4 ohm. So that way we have found the combination of A, B and C. Now our third case is the resistor A, B, C, D, all the resistors now. A, B, C, D. Now what we should consider, now we have already found A, B and C combination. This entire combination we already found out. This entire combination we have already found, that is nothing but the 4 ohm. Now I will consider this entire combination as a one resistor and B as another resistor. So this entire will be my R1 now, and this is R2. D is R2, A, B, C combination is R1. So I will use directly this formula, R total is equal to R1 plus R2. Okay, this formula I can directly use. So your R total here I can write down directly. Let's just select this to indicate, oh yeah, R total we are going to find out. R total is directly the addition because there are two direct combinations. So our first combination is nothing but the 4 ohm and the second combination is nothing but the 6 ohm. So total is nothing but the 10 ohm. So total is nothing but the 10 ohm, and I have to write down this once again over here, that will be 10 ohm. Okay, so I have just added R this 4 and 6. What is the 4? 4 is this my entire combination A, B and C, that is nothing but 4 ohm we found in the second part, and D is my uh, 6 ohm resistor. Okay, so in this case what I told you, this entire combination ABC is in series with D. So this combination is my first resistance R1, this D is R2, this combination is a 4, and this D is nothing but 6. That's why I have directly added. No need to write down formula again because it is just one mark question. So 4 plus 6 is nothing but the 10 ohm. Now we will move towards the B part of the problem. Now the part B of the problem, we need to find out the current in the battery. Okay. So we have already found the entire combination of the the resistance that was coming out to be the 10. So I will consider here this entire is nothing but the 10 ohm resistor. This entire is the 10 ohm resistor, and the current, we need to find out current will start from here, from the positive terminal of the battery, and current will flow through the circuit like this way. It will be just going like this. So I will assume this as a simple circuit. There is only one battery, 12 volt. This entire is a one combination only, that is nothing but 10 ohm. We don't want to consider this complex combination. We will consider this is only the one resistor, that is nothing but 10 ohm. Okay, because this addition of all these four is nothing but 10 ohm. And to find out the current, we will just apply the simple formula, that is nothing but Ohm's law. The Ohm's law is nothing but V equal to IR, and that's why I is what, if you are hearing the formula, you can find that I is nothing but V divided by R. Okay. So what is the V potential difference of the battery? That is a 12 ohm, 12 volt divided by the total resistance, that is nothing but the 10, and that's why our answer of the current is nothing but 1.2 ampere. Answer of the current is nothing but the 1.2 ampere. So I hope you understood this example. I will write again over here, that is 1.2 ampere. The current is measured in the ampere. So simply we are using the Ohm's law and we are calculating the volt is 12 and the overall resistance is nothing but 10 ohm. So 12 divided by 10 is nothing but 1.2 ampere. Now the energy transferred from battery to the circuit in 50 seconds. So if you recollect our energy is this. I have derived this formula using the power formula. Power was nothing but V into I. So energy is nothing but power into time. So power into time is nothing but Vi into time, because Vi is nothing but the power. Which also we can write on V square T by R, or we can write on I square TR. These two remaining formula we found using the Ohm's law, that is nothing but V equal to IR. So if you put in this first formula V is equal to IR, or if you put I is equal to V by R, then you can find out this formula. This entire thing I have derived in the lecture. So we will use this formula. This formula is used to find out the electrical energy or the heat also. So I'll use this formula to find out the energy transferred in the circuit for 50 seconds. So we'll use any of these. Okay, you can either use first, second, or third. I will use the first one because it's relatively simple. So here V I into T. Okay, this is nothing but our answer. Formula V is nothing but B12, which is already given. I we have found in this first part, that is 1.2, and the time given is nothing but the 50 seconds. Okay, so if you do the calculation in your calculator, you can find out the value of 720 joule. Okay, joule is the unit for the energy. So I can write down over here again, that is nothing but 720 joule. Okay, so we have to just simply use this formula. E is equal to VIT. We have to put the values. Potential difference 12, current is 1.2, time is 50 seconds. So answer is 720 joule. Now we will move towards the second problem. This is our second problem. You can see in figure 8.1, which shows three lamps and a fuse connected to the power supply. The EMF of supply is nothing but 220 volt. Each lamp is labeled. These are the ratings for each lamp, 220 volt and 40 watt. The rating of the fuse is nothing but the 2 ampere. So you can see this is the circuit. This is our power supply, that is 220 volt. EMF of the power supply is 220 volt. This is nothing but the fuse. This is the fuse, and these are the three lamps which are connected in the parallel combination. Okay, and the rating of the lamp is what? That is 220 volt and the 40 watt, and the rating of the this fuse is nothing but the 2 ampere. Now the current in each lamp. Our first question: calculate first part the current in the each lamp. Okay, so here we are going to find out the current in each lamp directly with the help of the Ohm formula, because in this case we can use to find out the current. There are so many formula. We can find out current is nothing but charge divided by time. We can find out current with using the Ohm's law also. We have already seen Ohm's law. Ohm's law is V divided by R. But there is another formula which is nothing but power. Here it is written power is nothing but V into I. So this three different formula, that is Q by T or V by I or this V into I is equal to P. This three formula you can use depending on the situation. Here no current flowing through the circuit is given. No charge is given. We can use directly the power formula because power ratings are given. Power ratings are what? 40 watt or 220 volt of the lamp, and we have already provided with the 220 voltage of the battery. So that's why we can use directly the power formula over here. So I will use this formula. P is equal to VI, that is electric power. So P is equal to VI, and that's why what is I? I is nothing but equal to, if you rearrange this formula, it will become P divided by V. Okay. If you use this rearrangement, this V will go to the going to the denominator, and I is equal to P divided by V. So what is the power rating? It is given, that is 240 watt, and the voltage is 220. So what is our answer? What is the current going through each circuit, each lamp? It is found. It is coming out to be 0.18 ampere. Okay, and you can write down over here. It is 0.18 ampere. Okay, this way the current is flowing through the each circuit. So how the current is flowing basically in this circuit? If you see the